Hi, welcome to Hashtag Math. We're going to talk about implicit differentiation. This is a different type of differentiation that we do when we don't have an equation explicitly given for y. Well, suppose we have a function of x, but you cannot solve for y. Something like x to the fourth power plus y to the fourth power plus 2xy equals 0. So you can write in some way y as a function of x. You can think of y as a function of x, but you cannot solve for y. For example, if you have a circle of radius 3, for example, x squared plus y squared equals 9, then when you want to solve for y is going to be positive or negative the square root of 9 minus x squared. And you cannot give a function of y because that is not a function. You have to separate this in two functions. One, the positive square root of 9 minus x squared, which gives you the top part of the circle. So just this top part, and negative square root of 9 minus x squared, which correspond to the lower part of the circle. You have to separate it into two. So how we do this, how we differentiate y. That's when implicit differentiation comes in. Suppose that y is a function of x. Then y squared is a composition of functions. The outer function being the square and the inner function is y, because y is a function of x. So look, when you write y squared, the outer function is the squaring and the inner function is y. Of course, we apply the chain rule. To find the derivative of this, not knowing how y looks like, but knowing that it's a function of x, we apply the chain rule. So put the 2 to the front and lower the exponent by 1, and that's the derivative of the outer function. But then you have to multiply by the derivative of the inner function. This is how you differentiate implicitly. Even though you don't know an equation for y, you can express the derivative of the inner function by attaching dy dx. Another example would be square root of y. That is again a composition. The square root is the outer function and y is the inner function. So to get the square root of y, when y is a function of x, you would do 1 over 2y, the derivative of the outer function in the inner function, and then attach dy dx as the chain rule says. Okay, let's work the next example. To derive implicitly, we start with our equation and derive on both sides. Then we split the derivative and take the constants out. We get 3 d dx of y squared plus d dx of sine y, and that equals, in this case, you don't have a y there. You just have x, so you derive as usual. You're just taking the derivative with respect to x of a function of x. So that's 20x to the fourth power. Then we derive as I did before. Keep the 3, and when you derive y squared, y is a function of x, so you do 2y, that's the outer function, and attach dy dx for the derivative of the inner function. So we are always applying the chain rule. Sine y is the outer function. The inner function is y. So the derivative of the sine is the cosine. Keep the y and then attach dy dx, the derivative of the inner function. And that equals 20x to the fourth power. Let's multiply the 3 here inside. And what is it that we want to find? We want to find that dy dx. And we have 2 dy dx here. We can factor dy dx and solve for dy dx, which is what we're looking for. So we get dy dx as a factor of 6y plus cosine y. And now we just divide both sides by 6y plus cosine y. So dy dx equals 20x to the fourth power over 6y plus cosine y. And that's it. That's dy dx, what we were looking for, the derivative of y with respect to x. And notice it's in terms of x and y. In this next example, I'm going to show how to take the second derivative implicitly. So we do the same. We have our equation and we derive on both sides and split it at the same time. The derivative of x to the fourth power is just 4x cubed. There's no y there. The next one is y to the fourth power. That is a composition because y is a function of x. So we do 4y cubed and attach dy dx, and that equals 0. Derivative of 16 is 0. It's a constant. Then we just solve for dy dx. So 4y cubed dy dx equals negative 4x cubed. And then divide both sides by 4y cubed and you get dy dx equals negative 4x cubed over 4y cubed. Cancel the 4 and we get that dy dx is negative x cubed over y cubed. And we found the first derivative. Now to find the second derivative, we have to derive the first derivative. So we have to do d2y dx squared, which is the derivative with respect to x of the first derivative, which we know is x cubed over y cubed. And we derive that implicitly. Notice that we have a quotient, and when we have a quotient, we do what? Yep, apply the quotient rule. The negative sign I'm going to put in the front, and I hope I don't forget to keep it there. So we do low d high minus high d low square the bottom, and away we go. So we have y cubed d dx of x cubed is just 3x squared minus x cubed we keep, and then we derive y cubed. Remember, y is a function of x, so chain rule must be applied. So we have to attach dy dx. So we derive the outer one, which is 3y squared, and then attach dy dx. So that equals negative 3x squared y cubed minus 3x cubed y squared. So now look what happens. We have that dy dx there that is disturbing us. We want everything in terms of x and y. Can you think of a way of getting rid of dy dx? Do we know what it is? Yeah, it's here. Okay, so we replace it. We replace that right here. And instead of writing dy dx, we write negative x cubed over y cubed. Keep your y to the 6th power there. And then it's going to equal 3x squared y cubed. Minus and minus is going to be positive. The 3 in the front. X cubed and x cubed together. It's going to give me x to the 6th power. And then this y squared cancels with that 3, and we just a y in the denominator and keep your y to the 6th power. Now add this rational expression. You just have to multiply and divide here by y over y to make them have a common denominator. So we get 3x squared y to the 4th power plus 3x to the 6th power all over y to the 6th power. And you know there's a 1 there. And this is just a complex fraction. Keep the numerator, 3x squared y to the 4th power plus 3x to the 6th power over y, and multiply by the reciprocal of the denominator. So we get 3x squared y to the 4th power plus 3x to the 6th power all over y to the 7th power. I'm forgetting the negative sign. Now look what I'm going to do. It's very interesting. And now I am going to factor everything that I can factor in the top. That is a 3 that repeats in both and an x squared that is in both. And then I'm left with y to the 4th power plus x to the 4th power. And look at this beauty. Look what x to the 4th power plus y to the 4th power is. It's just 16. So we may replace that 16 right here and makes everything prettier. Look at that. So our answer is going to be negative 48 x to the 2nd power over y to the 7th power. Isn't that nice? So we found our second derivative. The second derivative is negative 48 x squared over y to the 7th power. Yep, it took a little time. I didn't talk about the graph. If you take the same formula but squares, that would be a circle of radius 4, right? Some people call this the square circle. If you go x to the 6th power and y to the 6th power, it looks more like a square and more and more and more.